So this is going to be part 2 of probably 3 parts for section P5, and it's multiplication of a binomial times a trinomial. Disgusting. In order to do these multiplications, and you're going to be on this page doing 53 and 57, I'm going to take the first term in the first parentheses, multiply it separately by each of the 3 terms in the right parentheses, and then I'm going to take the second term in the left parentheses and separately multiply it by each term in the right parentheses. I'm going to get 6 multiplications and a bunch of like terms. So my first multiplication, I'm going to do 3x in the left parentheses times x squared in the right parentheses. Then 3x in the left parentheses times 5x in the right parentheses, 3x in the left parentheses times 3 in the right parentheses. So that's starting with the first term in the left parentheses, multiplying it by each 3 terms in the right parentheses. Move on to the negative 2 in the left parentheses and do negative 2 times x squared, do negative 2 times 5x, and do negative 2 times 3. First multiplication, there really isn't a coefficient of the x squared, or it's an implied 1. I'm going to multiply 3 times 1 and get 3. I'm going to add the exponent implied of 1 to the exponent of 2 and get an x cubed. Second multiplication, I multiply 3 times 5 and get a positive 15. I add the 1's that are implied on the exponents of the x's and get an x squared. Third multiplication, I multiply 3 times 3 and get positive 9, and I leave the x. Fourth multiplication, I'm just going to leave these written next to each other as a negative 2x squared. Fifth multiplication, I multiply negative 2 times 5 and get negative 10. I leave the x. Last multiplication, I do negative 2 times 3 and get negative 6. I have 6 terms here, but I have only 2 pairs of like terms. The like terms that I need to worry about are 15x squared minus 2x squared, and I need to worry about positive 9x minus 10x. The 15x squared minus 2x squared, that's easy because 15 minus 2 is just 13. That's going to be 13x squared. The 9x minus 10x is going to give me negative 1x. So in my answer, I'm going to have 4 terms, the 3x cubed and the minus 6 that were multiplications that didn't have any other terms like them to combine with, the positive 13x squared, the minus 1x as well. For an answer to 56, this would be perfect because it's written with the exponents in descending order, the constant term last. And I took the time to write a negative 1 in front of that x, and that's probably not necessary, but I kind of like it. But these would both be equally good answers for 54. I'm going to move on and do 58. You can do 57. I'm going to start with the 2a in the left parentheses. I'm going to multiply 2a times 5a squared. I'm going to multiply 2a times negative 2a. Multiply 2a times minus 3. And then I'm going to start with the 3 and do 3 times 5a squared, 3 times minus 2a, and 3 times minus 3. So I have the 6 multiplications that I need to do, each term in the left parentheses by each in the right. First multiplication, I multiply the 2 and 5 and get 10. I add the exponent of 1 and 2 on the a's and get an a cubed. Second multiplication, 2 times negative 2 is negative 4. I add the exponents of 1 on the a's and get an a squared. Third multiplication, I multiply 2 times negative 3 and get negative 6, and I leave the a. Fourth multiplication, I multiply 3 times 5 and get positive 15, and I leave the a squared. Fifth multiplication, I multiply the 3 times negative 2 and get negative 6, and I leave the a. Last multiplication, 3 times negative 3, and I get negative 9. Now I'm going to combine the like terms, which are the ones that have the variables with the same exponents. I need to combine the negative 4a squared and the positive 15a squared. And I need to combine the negative 6a and negative 6a. The 10a cubed and the minus 9 are going to be part of my answer, but they're not going to be involved in combining the like terms. So first, the minus 4a squared plus 15a squared. Just do minus 4 plus 15. And that gives me a positive 11. I did that sign, yes. So because they also have opposite signs, you just do 15 minus 4. So I'm going to get an 11 with the a squared. I'm going to bring down the 10a cubed. And I need signs between, and since this isn't negative, I'm going to put a plus sign between. The next terms, the minus 6a and minus 6a, the next set of like terms, I'm going to do minus 6 minus 6. Those have the same sign, so those are going to add. This will give me minus 12a. So if you're not comfortable doing the fractions, if you're not comfortable adding or subtracting with signed numbers, then just use your calculator. I don't have a problem with that. I'm going to bring down this minus 9, and I'm going to call this an answer. It's written in nice order. The exponents are going in descending order, and the constant's written last. So on this sheet, we're going to do 61, 65, and 69. There's almost so many of these that maybe I'll even ask you to skip 69. I'll skip 70. These are ridiculous problems. So if I'm doing 62, which is a twin of 61, I need to take each term in the left parentheses and multiply it by each term in the right parentheses. Or, better yet, maybe I'll rewrite, flip-flop the order to make it more like the last problem. So I'm going to flip, anytime I have a multiplication problem, I can reverse the order because multiplication is commutative. And if that reversing the order makes it easier to follow, then do it. It makes your work easier. So now I'm just going to do the 6 multiplications. 4x in the left parentheses by each of the 3 terms in the right parentheses. So 4x times 3x squared, 4x times 5x, 4x times 3, and then the minus 3 in the left parentheses by each of the 3 terms in the right parentheses. So minus 3 times 3x squared, minus 3, a dot for the times 5x, and minus 3 times 3. So each term in the left parentheses gets multiplied by each term in the right parentheses. Now I'll do the multiplications. This really doesn't equal the line above it because I don't have signs between, so I start writing my equal sign when I start putting the signs between. First multiplication, I multiply the 4 and 3 and get a 12, add the exponents on the x's and get an x cubed. Next multiplication, 4 times 5 is 20, add the exponents of 1 on the x's and get an x squared. It's positive, so I'll put a plus sign. Third multiplication, 4 times minus 3 is minus 12. I'll leave the x. Fourth multiplication, minus 3 times minus 3 is minus 9. I'll leave the x squared. Fifth multiplication, minus 3 times 5 is minus 15. I'll leave the x. Last multiplication, minus 3 times minus 3 is minus 9. Now I need to combine the like terms. I need to combine the 20x squared minus the 9x squared. That's just doing 20 minus 9. I need to combine the minus 12x and minus 15x. Those numbers have the same sign, so they're going to add. For my answer for 62, I'm going to bring down the 12x cubed. For this term, I'm just going to go 20 minus 9 and get positive 11 x squared. For that term, I do minus 12 minus 15, minus 12 using the minus by the fraction, negative 15, minus negative 12 minus 15 would be the proper way to say that. The first negative by the 12 is a negative by the fraction. The minus in front of the 15 is by the equal sign. Because those have the same signs, it's going to be a 27. with a negative sign. If they have the opposite signs, you subtract, the same signs you add. So that set of terms gives me a minus 27x, and I'm going to bring down the minus 9. And that's the best answer for 62. These next problems are redunculous. They're a trinomial times a trinomial. There's going to be 9 multiplications to do. So to do 62, I'm going to start off taking the 3x squared in the left parentheses and multiplying it by the 3 terms in the right parentheses. So I'm going to do 3x squared times 4x squared. I'm going to do 3x squared times minus 3x. I'm going to do 3x squared times 2. Now I'm going to move over to the 2x, and I'm going to multiply by each of the 3 terms in the right parentheses. I need to write smaller probably. So I need to do 2x times 4x squared. I need to do 2x times minus 3x. I need to do 2x times 2. Done with the 3x squared, done with the 2x. Now I'm going to move on to the minus 1 and multiply it by each term in the right parentheses. So I'm going to go minus 1 times 4x squared. I'm going to do minus 1 times minus 3x, and then minus 1 times 2. First multiplication, I multiply the 3 and 4 and get 12. I add the exponents and the x's. So that gives me a 12x to the 4th. Second multiplication, 3 times minus 3 is minus 9. I add the exponent of 2 and 1 on the x's and get an x cubed. Third multiplication, 3 times 2, so that's a positive 3x squared times a positive 2. It's this positive 3 times that positive 2, so 3 times 2 is positive 6, and I leave the x squared. Next multiplication, 2 times 4 is positive 8. Add the exponent of 1 and 2 on the x's and get an x cubed. Then 2 times minus 3 is minus 6. Add the exponents of 1 and 1 on the x and get an x squared. Next multiplication, multiply 2 times 2 and get positive 4. Leave the x. Then negative 1 times 4, get negative 4, leave the x squared. Then negative 1 times negative 3 and get positive 3, leave the x. And then negative 1 times 2 gives me negative 2. Ugh. Should have an equal sign here because this is equal to the line above it. Now I'll combine the like terms. The like terms are the minus 9x cubed plus 8x cubed, the plus 8x, the plus 6x squared minus 6x squared minus 4x squared, and then the plus 4x plus 3x. So those are the sets of terms I need to combine. I'm going to bring down the 12x to the 4th. It needs to be the lead term in my answer because it has the highest exponent. And then I'm going to worry about the negative 9 plus 8. I'm going to get a negative 1 to be in front of the x cubed. I'm going to skip writing the 1, but I can have it. Either I'm going to write negative 1x cubed or just negative x cubed. And then the next set of terms, I'm going to go 6 minus 4. I'm going to get a coefficient of negative 4 because the 6's cancel. So the next piece is going to be minus 4 for the x squared. I probably shouldn't have that big of a gap, but I just did. The 4x plus 3x is a 7x. So as an x, and bring down this minus 2. So for an answer, 12x to the 4th minus x cubed. You can certainly have a 1 in front of that x cubed if you prefer. Then minus 4x squared plus 7x, not that that looks like a 7x, but that is 7x, and then minus 2. My table seems really wobbly this morning. All right, so we're skipping 67, all right, or skipping 69, which is just, it's just another one of these, and I would never ask that on a test, it's just too much. So for the next page, we're starting to do these conjugate multiplications, and you should be doing 73, 77, you can't see it yet, but 81 on this page. We'll get to it in a little bit. So these are all 71 through 88 are multiplying conjugate pairs. Sometimes we also call those difference of squares, and that has to do with something that we get in chapter 1. It's just introducing some terminology that we get in chapter 1. But when we have the multiplication of two binomials that are identical, in terms of the variables, a y here and a 5, a y and a 5, and have opposite signs, we either call those conjugate pairs or difference of squares. And after I do a couple of these, you might find a way to be efficient in your multiplying. So I'm just going to do generic foiling for problems 74 and 78. And then I'm going to try to develop a shortcut to get to the answer, which you might already know, which would be good. But if I didn't know a shortcut, there is a shortcut when you're multiplying differences of squares, which are the same as conjugate pairs. I could just go y in the first parentheses times y in the second parentheses. That's the first part of this. And then y in the left parentheses times negative 5 in the right parentheses. That's the outer part. 5 in the left parentheses times y in the right parentheses. That's the inner part. And then 5 in the left parentheses times negative 5 in the right parentheses. That's the last part. First, y times y is y squared. Outers, 5 times minus y times minus 5 is minus 5y. Inners, 5 times y is positive 5y. Lasts, 5 times negative 5 is minus 25. When you're multiplying conjugate pairs or equivalently difference of squares, when you get to the simplifying part, these outers and inners, the middle terms, will always cancel. So you don't really have to do the outers and inners part of the work. I should write an equal sign when I get to this line because it equals the line above it. For an answer, I'm just going to get y squared minus 25. Your answer when you're multiplying conjugate pairs or differences of squares is always just going to be a binomial. The multiplication, if you do it all, gives you 4 terms, but you only get 2 terms in your answer. I should have done 74, but it doesn't matter. I'll skip 74 and go down to this ugliness of 78. I'll do 78 full-fledged, and then after this I'm going to start skipping. So for 78, I'm going to do it up here. I'm going to multiply the firsts of y times y, the outers of y times negative 4/5, the inners of 4/5 times y, and the lasts of 4/5 times negative 4/5, just using those terms because you might hear them frequently in a higher class. But basically I just take any term in the left parentheses, multiply it by both terms in the right parentheses, one at a time. First multiplication, y times y is y squared. This is why I write my equals, because now it's going to really equal because I'm going to put the signs between. Second multiplication, positive times the negative is a negative. And if I multiply a fraction by a letter, I just write those next to each other. So that second multiplication would just be minus 4/5 y. Third multiplication, they're both positive, so I'm going to write a plus sign. And I'm just going to leave that 4/5 y alone. Last multiplication, I multiply across the numerator. 4 times 4 is negative 16. I'm going to write the negative sign first, the 16 in the numerator. And then in the denominator, 5 times 5 is 25. Always, when I go to multiply conjugate pairs, I should try to be efficient because you don't have to do all 4 steps of foiling, because the outers and the inners, if you actually name these, will always be opposites and they'll always cancel. So when we're living in the world, if I can look at a multiplication of binomials and realize that it's a difference of squares multiplication or a conjugate pairs multiplication, then I don't have to do the outers and the inners. And that's in the instructions where it says try to be efficient. I try to be efficient by skipping the stuff that I know is going to cancel. So for an answer for 78, it's going to be y squared minus 16 over 25. All of the problems up through 88 are conjugate pairs. 82 is written in a bad order with the higher power term second, but it's still conjugate pairs. I have two identical parentheses. They both have 4 and a 3x squared. One has a plus, one has a minus. We either call these conjugate pairs or differences of squares. In order to do the multiplication, I just have to do the firsts and the lasts, which I could probably do in my head, because the outers and the inners, when you're multiplying differences of squares, are equivalently conjugate pairs. The outers and the inners will cancel. So to be efficient in my work, when it gets asked, I'm going to not do, this is inefficient. If I know these are going to cancel, why do them? So if I identify something as a conjugate pair or equivalently difference of squares, you can be efficient and just do the firsts and the lasts. In problem 82, the first would give me 16. For the lasts, I multiply 3 times negative 3 and get negative 9. I add the exponents on the x's and get x to the 4th. This is an okay answer, but it's not written in the nicest order. Usually we take the time to rewrite an answer with the highest power first and have the exponents go in decreasing order. So a better answer for 82 would be negative 9x to the 4th plus 16. But quite honestly, this is probably okay. It's not written in the best order, but the original problem wasn't written in the best order, so that just kind of spilled over. So on this sheet, we're going to be doing 85, 89, and 93. 85, all these problems are differences of squares, are conjugate pairs, so I really just need to do the first multiplication and the last multiplication, because the other two multiplications will cancel. So for 86, I just need to do 2x times 2x and negative 7 times 7. 2x times 2x equals 2 times 2 is 4, x times x is x squared, minus 7 times 7 is minus 49. So I get 4x squared minus 49 for my answer. Had I did the other multiplications, if I did 2x times 7, I would have gotten a positive 14x. Had I did minus 7 times 2x, I would have got negative 14x for the other two terms, and those would cancel. 89 through 106, I'm multiplying. These aren't differences of squares. These aren't conjugate pairs. These are identical polynomials. If you're multiplying identical polynomials, that can be rewritten with an exponent, because an exponent is a shorthand for repeated multiplication. Problem 90, I'm doing repeated multiplication of y plus 5s. Shorthand is y plus 5 squared. In problems 86, 88, those can't be rewritten with an exponent because I'm not multiplying identical terms. So when I do problem 90 that I'm about to do, it's equivalent to doing this problem. These are equal to each other, but problem 90 is probably better in the way it's written, even though it's the same. If you try to multiply this out, you might mess up. This is not as easy to mess up. So in problem 90, I'm going to do the foiling. I'm going to multiply the y times the y in the left parentheses, the y in the left parentheses times the 5 in the right parentheses. I'm going to multiply the 5 in the left parentheses by the y in the right parentheses, the 5 in the left parentheses by the 5 in the right parentheses. The first, y times y is y squared. The second, y times 5 is positive 5y. The third multiplication, 5 times y is positive 5y. And the last multiplication, 5 times 5 is 25. When you're multiplying identical binomials, which we call these squares, if you're multiplying two identical binomials, we call that multiplying squares because it can be rewritten with an exponent. The outers and the inners, or the middle terms, don't cancel. For an answer to problem 90, it's going to be y squared plus 10y plus 25. Had the questions said to simplify y plus 5 squared, you can't just square the y and square the 5. The rules that we had in section P1 about distributing an exponent through a parentheses didn't work if there was a plus inside a parentheses. The quantity y plus 5 squared, it's going to simplify to y squared plus 10y plus 25. And if I was asked to multiply that, I'd rewrite it with its two parentheses, and then I'd do the foiling. Problem 94, which I'm about to do next, that's the same as asking me to multiply 3b to the fourth minus 8 quantity squared. This problem that's given to me and that problem that I've just written are the same. They mean the same things because multiplying two identical binomials is longhand for that binomial squared. Squaring something means to multiply two identical copies. So let me do the four multiplications here. I'm going to do the 3b to the fourth in the left parentheses by the 3b to the fourth in the right parentheses. And I'm going to multiply it by the negative 8 in the right parentheses as well. I'm going to take the negative 8 in the left parentheses and multiply it by the 3b to the fourth in the right parentheses and the negative 8 in the left parentheses times the negative 8 in the right parentheses. That would be the exact same algebra I would do if the problem asked me to simplify 3b to the fourth minus 8 squared, because I can't just square each term. If there's an addition or subtraction inside a parentheses, you can't just square the terms. So my multiplications now, first multiplication, I multiply the 3's and get a 9. I add the exponents on a b and get a b to the 8th. Next multiplication, 3 times negative 8 is negative 24. I leave the b to the fourth. Third multiplication, negative 8 times 3 is negative 24. I leave the b to the fourth. Last multiplication, negative 8 times negative 8 is positive 64. I need to combine these terms. They don't cancel. In order for those terms to cancel, they need to have opposite signs. These terms are a negative 24 minus 24, and those are combined to a negative 48. So for an answer for problem 94, I'm going to get 9b to the 8th minus 48b to the fourth plus 64. Getting kind of long, but I'm going to do a couple more problems. Well, there's some fraction problems. So I'm going to do 97, 101, or you're going to do 97 and 101, and maybe I'll do 97 with you so you don't have to fight the fractions by yourself. So 97, it is the same as asking you to do 3y plus 2/7 quantity squared. Had the problem said find 3y plus 2/7 quantity squared, the answer to it's going to be the same as the answer to that, because that's what this means. So four multiplications. First multiplication, take the 3y in the left parentheses, multiply it by the 3y in the right parentheses. Take the 3y in the left parentheses, multiply it by 2/7 in the right parentheses. Done with the 3y, move on to the 2/7. Do the 2/7 in the left parentheses by the 3y in the right parentheses, and the 2/7 in the left parentheses by the 2/7 in the right parentheses. First multiplication easy. I just multiply the 3's and get a 9. Now I'm going to write equal signs because I'm going to have signs between additions or subtractions between. Multiply the 3's, multiply the y's. Second multiplication, in the third multiplication, I need to be able to multiply the 3 and the 2/7. In order to multiply 3 with 2/7, I should think of it as 3 over 1 times 2/7, and then I can multiply across the 3 and 2 and get 6, across the 1 and 7 and get 7. This second multiplication, it's going to be both positive, so I get a plus sign, and when you multiply 3 times 2/7, you get 6/7. The third multiplication, I have to multiply 2/7 times 3, and to do 2/7 times 3, it's really 2/7 times 3 over 1. I multiply across the top. 2 times 3 is 6, 7 times 1 is 7. That third multiplication is going to give me another 6/7 y. And then the last multiplication, I do 2 times 2 and get 4. Multiply across the numerators and across the denominators. They're both plus, so the sign between is going to be a plus. The numerators 2 times 2 is 4. The denominator 7 times 7 is 49. I'm going to combine the 6/7 and 6/7 y. I'm going to do 6/7 plus 6/7. And that's super easy. 6/7 plus 6/7 is just 12/7. Those fractions in front of the y's have the same denominator, so I'm just adding the 6's in the numerator. So for an answer for year 97, I'm going to get 9y squared plus 12/7 y. That y could be in the numerator or written off to the right, plus 4/49. So I'm going to write an or here. That middle term, its y can be shoved up in the numerator, and that's still going to be equal to the original problem. Maybe one more, and I'll pause this part, or maybe 2 more, because we're almost done with this grouping. 101 and 103 are kind of twins. 102, should I say. 102 is the same as asking me to find y cubed plus 4 quantity squared, because multiplying 2 identical binomials is longhand for the problem written with an exponent. So to do 102, I'm going to multiply the y cubed in the left parentheses by the y cubed and the 4 in the right parentheses. I'm going to multiply the 4 in the left parentheses by the y cubed and the 4 in the right parentheses. First multiplication, I add the exponents on the y's and get a y to the 6th. Second multiplication, I'm multiplying 2 positives, so I get a positive. I leave the 4 and the y cubed next to each other. Third multiplication, they're both positive, so I put a plus sign. I leave the 4 and the y cubed next to each other. Last multiplication, 4 times 4 is 16. And now I'm going to combine the 4y cubes by adding the 4's in front of them. And for my answer, I get a y to the 6th plus 8y cubed plus 16. And that's written in a nice order. So on the next page, you should do 105 to start. I should do 106 to start. So let's just do these, and then we'll do a part 3 to this video. Problem 106, it's longhand for asking me to do 7 plus 3y squared. This problem, 7 plus 3y squared, it's illegal just to say it's 49 plus 9y squared. When there's addition between the terms, you can't just square the terms. You have to do all 4 parts of FOILing. So for 106, I'm going to multiply 7 times 7. I'm going to multiply 7 times 3y. I'm going to multiply 3y times 7. I'm going to multiply 3y times 3y. My first multiplication, 7 times 7 is 49. My second multiplication, I multiply the 3 and 7, get 21. I leave the y. My third multiplication, I multiply the 3 and 7 and get positive 21. I leave the y. My last multiplication, I multiply the 3 and 3 and get positive 9. I multiply y and get y squared. When I go to write my answer, the 49 needs to be written last because it's the constant. The 9y squared needs to be written first because it's the highest exponent term. And these middle terms don't cancel because they have the same signs. So first I'm going to write 9y squared. Last I'm going to write positive 49. And in the middle I'm going to go 21y plus 21y. I'll add the 21s and get 42y. So the answer to 106 is going to be there. Eventually, we'll finish up this sheet, but I'm going to do a part 3 to this video.